Assalamualaikum and good day. My name is Siti Fatimah Binti Hjh Ahmad Zabidi. I'm from Center for Mathematical Sciences, Universiti Malaysia, Pahang. Today I'm going to show you how to find the center of gravity of LAMINA. This is 4.7.3 part 1. Now I would like to explain to you the meaning of center of mass and center of gravity and what's the relationship between the two. Center of mass is the point at which the distribution of mass is equal over all direction and does not depend on gravitational field. Whereas center of gravity is the point at which the distribution of weight is equal in all direction and it depends on the gravitational field. Please take note that in our module, we use center of gravity instead of center of mass because we know that center of mass is equal to the center of gravity if the gravitational field is constant throughout the lamina. So most of the lamina around us is basically having constant field throughout the lamina. Now let's look at the formula used to find the center of gravity of lamina. Center of gravity denoted by x bar y bar of lamina occupying the region R and having the density function delta xy is given by these two formulas. X bar is moment about the y-axis divided by the mass, and y bar is moment about the y-axis divided by mass. Now, we want to know what is the meaning of moment. My is denoted for moment about the y-axis. Mx is denoted for moment about this x-axis. So, what is the meaning of moment? Moment is the tendency for mass. If mass is placed on the level beam, the tendency for it to rotate. Okay. Now you compare figure A and B. Figure A, you have the same mass placed in the level beam. Same mass, but distance is different. For A, the distance of the mass to the fulcrum is less compared to the one in B, which is further away from the fulcrum. You notice that the tendency for mass in A to rotate is less compared to the one in B. So with the same mass, but the distance is different, the tendency for rotation is also different. Okay. Now let's look at figure C and figure D. Now figure C and figure D, you notice that the distance of the mass from the fulcrum is the same. Okay. But the mass is different. You notice that the tendency for mass in C to rotate is less than the one in D, meaning that moment depends on mass and also distance. So you can say moment depend on mass and distance. Now I would like to explain to you what is the meaning of moment about the x-axis and moment about the y-axis. Moment of a particle about an axis is the product of its mass and its directed distance from the axis. So if we imagine lamina to be of that shape, you can divide the lamina into small parts and you have a particle here. So let's say the particle is somewhere here. Then the distance of that particle to the y-axis is the y value. That's why if you want to find moment about this x-axis, you multiply the distance, which is y value, times by the mass, and you know the mass is density times by area of the lamina. Okay? Like so for my. For my, we multiply with the mass. The mass is density function times by the area. And the distance from the y-axis. You notice that the distance from y-axis is the x value. So remember, don't get confused. Moment about this x-axis, you multiply the y value with the density function and you integrate that double integration using double integration with respect to dA. And moment about the y-axis, you multiply by the x value for this density function and you integrate that with respect to dA. Now let's look again at the formula used to find center of gravity of lamina. Now, center of gravity of a lamina, if you can imagine, if you have a lamina of that shape and it's placed on a pencil or some tip like this, it balances out. So, to find the center, remember, we need to find the moment about the y-axis, distance from the y-axis times by the mass, and moment about the x-axis, distance from this x-axis times by the mass. Now in the example 4.7.3.1, a triangular lamina with vertices 0, 0, 0, 1 and 2, 0 has density function delta xy equivalent to xy. Now you need to find the center of gravity of this lamina. Remember, we used the same lamina in the example 4.7.2.1 in previous video. And in that video, we found the mass of that lamina to be equivalent to 1/6. That means m value of this lamina is 1/6. Now we want to find the center of gravity. So center of gravity x bar is defined by moment about the y-axis divided by the mass. Now we know the formula for moment about the y-axis is the double integration of the distance from the y-axis, which is x value, and the mass. This is the mass. Density times by the area is the mass. So we multiply the x and x here to give you x square here. Okay, and since we integrate with respect to y, x square is fixed. So we can put it outside the first integration. So we integrate this y here to give y squared divided by the power, which is 2. And then that 2 here is 1/2 and we put it outside the integration. So we substitute the value for y, become 1/1 minus x/2, which is the y value here. Okay, y value here, minus when we put 0 here, we get 0 for y. So we end up getting x squared times by 1 minus x/2 squared. We expand this value here to give this value. So when we multiply x squared here, we will get x squared here, we will get x squared here, and x squared times by x will give you minus x cubed here, x squared times by x squared divided by 4 will give you 1 over 4 x to the power of 4. Then we integrate with respect to x. So increase the power of 2 here by 1, you get x to the power of 3 divided by 3. And then integrate this one here. So x to the power of 3 becomes x to the power of 4 divided by 4. And x to the power of 5 here. X to the power of 4, you increase the power by 1 to get 5. But that 5 times by that 4 will give you 20 here. So you now need to substitute the values of 2 for the upper limit. 2 to the power of 3 will give you 8. Divide by 3. X to the power of 2 here. Divide by 4 will give you 4 here. Substitute 2 for x to the power of 5 here. You get 32 divided by 20, and that will give you that value. So you simplify, will get half. 4 over 15 cancels off 2 and 4 here, will give 2 over 15. So that will give you the value of moment about this y-axis. Now let's find what is y bar. Y bar is moment about this x-axis divided by mass. And you know that the moment about this x-axis is the distance from this x-axis, which is the y value, times by the mass. So mass is density function times by small area. And that small area is dy dx. This is type 1 region. We use type 1 region. So y times by y will give you y squared. So we have y squared times by x, and to integrate y squared, you integrate, you will get y cubed divided by 3. Notice that x here is fixed because we integrate with respect to y. So we just leave the x alone here. Now 1 over 3 is a constant. So we just put it outside. To make our calculation simpler, we just bring the constant outside, the integration. So when we substitute values in for y cubed, okay, y we substitute it for 1 minus half x. So we have this value for y cubed, because this value is y cubed. So you need to expand this. There are many ways of doing. You can use this formula here if you like. This one is using Pascal number. If you don't remember this formula, you can just expand it normally. So I use this formula and then substitute the values for a here. Since a value is x over 2, I just substitute in that formula, the one in red. So a value is x over 2. So 3a will give you 3x over 2. 3a squared will give you 3x squared over 4. And you minus a cube minus a cube. A cube is x over 3 divided by 2 to the power of 3, which is 8. So you get this value. Remember, you need to multiply by the x here. So 1 here, you times by x to get x. Negative 3 over 2 times by x will give you that value. 3 over 4x squared times by x will give you this value. Minus 1 over 8x cubed times by x will give you that value. Now, we need to integrate with respect to x. So increase the power of, for x here, power 1 become x power of 2 divided by the new power. This one is x to the power of 2. You increase the power by 1 to give you x to the power of 3. So you divide by 3, that 3 and this 3 cancels off to give you 1 over 2, x cubed. And the power x cubed here, you increase the power by 1 to give you x to the power of 4. And you divide by the new power will give you 16. X to the power of 4, you increase the power by 1 to give you x to the power of 5. You divide by 5, 5 times by 8 will give you 40. So when you substitute values in for x, so x squared will give you 4. 4 divided by 2 will give you value 2 here. Then x to the power of 3, you substitute 2 in, you get 8 divided by 2 will give you 4. X to the power of 2 to the power of 4 divided by 16, it give you 1. So this is 3. X, you substitute x here. So 2 to the power of 5 will give 32. Divided by 40, it gives you this value. And that value here is 1. 1 minus 1 over 4 will give you 1 over 5. So you multiply 1 over 3 times by 1 over 5 to give this value. Remember, just now we have moment about the y-axis to be 2 over 15. If you divide by the mass, you will get 4 over 5. So that will give you the value for x bar. For by bar, we notice that the value of moment about this x-axis is 1 over 15. You will divide by the mass, which is 1 over 6, to give you 2 over 5. So the center of gravity of that lamina is 4 over 5 and 2 over 5. So this is the x bar and this is the y bar. So I hope you understand this example and try to do the exercises that I will give to you in the next slide. Okay? Thank you. In these two exercises, I need you to find the mass and center of gravity of lamina. Number 1, the lamina occupies the region bounded by this graph, this line, this x-axis with the density function x plus y. In the next exercise, I need you to find the mass and center of gravity of triangular lamina with vertices 0, 0, 0, 1, 1, 0 and density function is x times by y. The answer for number 1 is given here and the answer for number 2 is given here. So please do exercises so that you understand the lesson.